is method. In this method, we'll be making use of Euler's identity. Sum the series sin alpha plus x sin alpha plus beta plus x square by 2 factorial sin alpha plus 2 beta plus etc. Here we call the given series as S and the corresponding cosine series as C. The cosine series is obtained by just replacing every sine function by cosine function. Once you have obtained sine and cosine series, you just take C plus IS, or you just take cosine series to which you add I times every term of the sine series given. After that, we group terms containing x square by 2 factorial and groups which does not contain x. We obtain the terms grouped in this format. Cos alpha plus I sin alpha can be replaced by e raised to I alpha, because by Euler's identity we have cos theta plus I sin theta equals e raised to I theta. If you replace theta by alpha plus beta in the Euler's identity, you obtain this term. Therefore, you have cos alpha plus beta plus I times sin alpha plus beta equals e raised to I alpha plus beta. If you replace theta in the Euler's identity by alpha plus 2 beta, you get this term. So by the same Euler's identity, we have this term replaced by e raised to I alpha plus 2 beta. Whenever cosine of an angle plus I times sine of the same angle format terms appears, you can make use of Euler's identity, and the power will be the angle which has appeared along with the cos and sine functions. The angle actually appears with the power of the exponential function along with I as the coefficient of I. After applying Euler's identity to each term, we obtain an expression like this. Notice that e raised to I alpha is common to all the expressions, because you can write e raised to I alpha plus beta as e raised to I alpha into e raised to I beta. Similarly, you can write e raised to I alpha plus 2 beta as e raised to I alpha into e raised to I 2 beta. Therefore, e raised to I alpha is common to every term in the series, so you take outside it and you are left out with this series. Recall that exponential function e raised to x can be written as e raised to x equals summation x raised to n by n factorial, where n ranges from 0 to infinity. That is, e raised to x can be written as 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus etc. If you replace the variable x by x e raised to I beta, because x is only a general variable, it can be replaced by any input. If you replace x by x e raised to I beta, you obtain this series. So this series is nothing but e raised to x e raised to I beta. The only difference is that instead of the usual e raised to x function, in place of x you have x e raised to I beta. So this expression can also be written as e raised to the power x will be of the format x e raised to I beta. Now in the resultant expression e raised to I alpha into e raised to x e raised to I beta, if you replace e raised to I beta by the same Euler's identity, e raised to I beta equals cos beta plus I times sin beta, you will get this expression, and this is of the form e raised to x into e raised to y. We have e raised to x into e raised to y written as e raised to x plus y. So these two powers can be added up, and you separate the real and imaginary part of the power of e. Then you obtain e raised to x cos beta plus I times alpha plus x sin beta. And you again apply the same result, e raised to x plus y equals e raised to x into e raised to y. That is, this expression e raised to m plus n can be written as e raised to m into e raised to n. You used the same identity again, because you can now replace e raised to I theta as cos theta plus I sin theta, where theta equals alpha plus x sin beta. So you are again and again applying the same Euler's identity, because you want to get the expression of S. So after applying the Euler's identity, now you multiply the exponential function inside and you have separation of real and imaginary parts on both sides. This expression we started with c plus is. So in both sides, when you equate the imaginary part, you have s equals e raised to x cos beta into sine alpha plus x beta. This is the application of Euler's identity to find out sum of a series, and this method is known as c plus is method because similar to the sine series given in the question, we are depending on the cosine series as well, and we are framing a new series c plus is to which we wish to apply Euler's identity several times to get the exact expression of the sum of the given sine series.